Welcome to the VIAVI Geo Location xApp demonstration, unlocking location intelligence, powered by VMware Distributed RIC. As communication services providers, or CSPs, adopt RAN programmability to onboard technology for automation and optimization of RAN resources, they are discovering that access to precise real-time location of UE devices and to subscriber-centric geolocated KPIs data is of utmost importance to realize the full potential of these new operational models. VIAVI Geo Location xApp, powered by VMware Distributed RIC, unlocks the power of location intelligence for RAN automation and optimization. VIAVI's xApp accurately geolocates subscribers' every interaction with the network to provide location as well as subscriber-centric KPIs for consumption in the near real-time domain. The business impact is immediate. Using VIAVI's xApp, CSPs can efficiently enhance the end-user service experience thanks to location-enriched apps which take better and informed subscriber-centric decisions. CSPs can also drastically reduce OpEx through location-enriched automation of network operations, can improve overall spectrum and RAN energy efficiency with spatial insights on network coverage and usage. And finally, VIAVI's xApp can unlock new data monetization revenue streams for CSPs by leveraging insights from subscribers' mobility. So how does VIAVI Solutions' unique technology work? The xApp is composed of a parser module responsible for decoding the ASN1 message and parsing the relevant serving and neighbor cell information from the RRC messages. The segment generator module is responsible for breaking up the subscriber's connection into several segments. And finally, the geolocation module, which applies VIAVI's proprietary algorithm to geolocate the segments, providing insights into subscribers' mobility and the QoS. VIAVI's Geolocation xApp provides a foundational capability on VMware Distributed RIC by exposing the rich subscriber-centric information through VMware SDK libraries such as SDL API and the Inner xApp API. This enables other xApps to make better decisions. In this demo, we are going to show how the xApp can ingest the network measurement data to produce a real-time feed of subscriber geolocated segments. To demonstrate and validate the Geolocation xApp, we use VIAVI and VMware's Testbed as a Service framework. Composed of the VMware RIC and SDK and the VIAVI RIC tester, Testbed as a Service accelerates application development by offering a platform with pre-integrated RIC and RIC tester, pre-built test cases, standardized testing methodology, and easy-to-use reference AI and ML training data that help developers conduct cloud-based training and performance validation of apps to underpin revenue generation. In our case, the testbed has been configured to emulate a network deployment represented by 300 emulated UEs, moving around 5 emulated cell sites. Let's activate this scenario. With an already deployed VMware Distributed RIC instance, we launched the VIAVI Geolocation xApp using standard Kubernetes commands. We can see that it deployed correctly and connected successfully to the distributed RIC. VIAVI RIC Tester's UI enables scenario configuration and execution. In particular, we can use the UI to define the number of GNB nodes and sites per node of our simulation. In our demo, we have 1 GNB and 5 sites. We can also define the RF conditions per site, for example, rural versus urban, and the number of subscribers that are moving in the area, 300 in this case, with their associated traffic profiles. The resulting model is shown here, where we can easily identify the 5 sites and the distribution of the 300 UEs per site. Let's now activate the simulation and verify that the Testbed as a Service scenario is running properly. The scenario looks good. With the testbed up and running, let's proceed with the analysis of the geolocation in operation. As the application starts to ingest and process data, we examine the logs produced. The Geolocator xApp is in verbose mode and reports the various measurements that it is producing to estimate the mobile locations. The xApp needs a definition of the network it is operating on, including the characteristics and parameters of the cells. The Geolocation xApp harvests measurements that contain rich information about the radio. Consuming and analyzing this data facilitates the location estimation and a rich set of analytics for data-driven optimization. Now let's look at how the geolocation can be put into action. Availability of geolocation estimates in near real time is foundational to enhancing many near real-time use cases that make decisions about how to manage individual mobile connections. But aggregating the data has even more potential. Aggregating the measurements and locations of mobiles over longer periods reveals the dynamics of the mobile behavior and how the radio network responds to this. This unlocks a wide range of data-driven optimization use cases to tailor the network to the demands placed on it. The benefits are clear. Thanks to VIAVI Geo Location xApp as a foundational capability supported by the VMware Distributed RIC, CSPs can maximize RAN optimization with a focus on enhancing the overall subscriber quality of service, leading to reduction in churn, OpEx savings by enablement of automation use cases, and new revenue stream generation through data monetization.